Alright, so we can now move on to section 3.2, which is basically just adding on to what we did in section 3.1, and that is the derivative as a function. Definition. So what we did in section 3.1 was I learned how to find f prime at a point, right? So I always said f prime of 1, f prime of 2, right? Now I just want it as f prime of an x, just a plain an x. I'm not going to actually plug in a number for x. So let f be a function. The derivative function, which is again denoted as f prime, is the function whose domain consists of those values of x such that the following limit exists, and that is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So this is the exact same thing we have done, except now I'm not going to plug in a number for x. Okay, I'm going to just leave it as x. But the process is the same. So let's do some examples. Let's let f of x be equal to x squared, and I'm going to say find f prime of x. So, like I said, what I have done is I plugged in a number for the x, right? But now I want to just leave it as an x. So, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So for f of x plus h, I'm going to just plug that in. So that's going to be the limit as h goes to 0 of x plus h squared minus f of x, which we have up here as x squared, all over h. Let's work this out and see what happens. That's the limit as h goes to 0. X plus h squared, remember I do it twice, right? I would do x plus h times x plus h, and you would get x squared plus 2xh plus h squared, and then I still have this minus x squared hanging out right there. Let's see what happens. I can do x squared minus x squared, so those are canceled out. So I'm left with the limit as h goes to 0 of 2xh plus h squared over h. Notice here every single term here has an h, so I can cancel out an h from all of these things. So that's going to give me the limit as h goes to 0 of 2x, and I'm left with just 1h. So now I can plug in 0 for the h, which would just give me 2x. So f prime of x is equal to 2x. So the good thing about that is now that I have this, if they ask for f prime of 2, I could just plug in 2. If they ask for f prime of 3, I can just pull again the 3. So having this means I can find f prime of whatever x I want to. Let's do another example. Let's let f of x be equal to the square root of x, and we're going to find f prime of x. So again, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Plug in an x plus an h, and that's going to be the square root of x plus h minus, plug in an x, square root of x all over h. Like we have done, we're going to multiply that by the conjugate to get rid of the square roots. So square root of x plus h plus the square root of x. Same thing on the denominator. Again, the reason we do that is because we learned what I can do now is just square my first term. The square root of x plus h squared would just be x plus h, and then minus this term squared. The square root of x squared is just x all over h times square root of x plus h plus the square root of x. What's good there is now x minus the x, they cancel out. So that's just the limit as h goes to 0 of h over h times the square root of x plus h plus the square root of x. Now I can cancel out that h. So we just have the limit as h goes to 0 of 1 over square root of x plus h plus the square root of x. And that's good because now I can just plug in 0 for the h. So that's going to be 1 over square root of x plus the square root of x. So 1 over 2 square roots of x. 1 over 2 square roots of x. Again, I like this because now I can just plug in a number for x. And that's helpful. Let's do another example. Let's let f of x be equal to x squared minus 2x, and we're going to find f prime of x. So once again, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're going to first plug in the x plus h. So that's the limit as h goes to 0 of x plus h squared minus 2 times x plus h minus f of x. So I'm going to subtract x squared, which would then make this plus 2x because I am subtracting it, all over h. Simplifying this as best as we can, x plus h squared we've already seen as x squared plus 2xh plus h squared. Distribute to the negative 2. That gives us negative 2x minus 2h. And then I still have minus x squared plus 2x all over h. Let's see what happens now. Notice I have x squared minus x squared, so those cancel out. Then I have negative 2x plus 2x, so those are out too. So this is now the limit as h goes to 0 of 2xh plus h squared minus 2h all over h. And that is a good thing because now every single term has an h. So we can cancel out every h. That leaves us with 2x plus 1h minus 2. And now that I have that, I can plug 0 in for the h. So you're going to get 2x minus 2. 2x minus 2 is the derivative of x squared minus 2x. So up until now, we've only seen this as f prime, right? But there are other ways to write it. There are other ways to write it. So here are some different notations. So you've already seen f prime of x, and that's good. But it might also be written as dy over dx. Remember we said f prime is a slope, and so this is the same thing as a slope. Change in y over the change in x, so it might be written that way. Sometimes you'll see it written as y prime. So like if I have y equals 2x plus 2 or that kind of thing, if I ask for y prime, that means it's the derivative. So I would do the same thing. And then another way you might see it is as d over dx of f of x. All of this means the same thing. All of these mean take the derivative. That's what all of these mean. It's just another way to write the same thing. So let's do an example where they use a different notation, but they're asking for the same thing. Example. Find d over dx x cubed. So even though this doesn't look the same, this is the same thing as saying find the derivative of x to the third. So that's what I want to do here. Find the derivative of x to the third. So do this the same way. d dx x to the third is equal to the limit as h goes to 0. Plug in x plus h, right? So that's going to be x plus h to the third minus, just leave it, x to the third, all over h. And now work that out. X plus h to the third, let's figure out what that is. Well, I know x plus h times x plus h is x squared plus 2xh plus h squared. So now do x squared times x, which is x to the third, x squared times h, just leave that as x squared h. 2xh times x is 2x squared h, because I would have in there x times that x. 2xh times h would be 2xh squared. H squared times x is xh squared. H squared times h is h to the third. Combine like terms there. X cubed, there's only one of those. X squared h plus 2x squared h gives us 3x squared h. 2xh squared plus xh squared gives us 3xh squared plus h to the third. So that gives us the limit as h goes to 0. X plus h cubed is x cubed plus 3x squared h plus 3xh squared plus h cubed. And then I still have minus x cubed all over h. Now that we have that, I'm going to erase it. Simplify this as much as I can. Notice I have x cubed minus x cubed. So those are out of there, which leaves us with 3x squared h plus 3xh squared plus h cubed all over h. All of these terms have an h, so we can cancel all of those out, which leaves us with the limit as h goes to 0 of, this would become just 3x squared, that would become 3xh, that would become h squared. Now I can plug 0 in for the h, and that would give us 3x squared, 0 here and there. So it's just 3x squared. So my point here was, if you see it like this, it's the same thing as saying f of x equals x cubed, find f prime of x. The same thing. Some other notations you might see are these. If you see f double prime of x, so if it's an f with 2 primes, that is the second derivative, which basically means it's the derivative of the derivative. So I'm doing it twice. You might also see it written as y with 2 primes. You might also see it as d squared y over dx squared. Any of those means I'm going to do it twice. If you see f with 3 primes, that is the third derivative, which means I'm doing it 3 times. Again, you might see it written, that should be 2 primes. You might see it written as y with the 3 primes. You could see it written as d cubed y over dx to the third, all of that. Anything beyond 3, it won't be primes. It'll be written like f parentheses with whatever I have. So I'll just say an n. That is the nth derivative. Anything over 3, we do that instead. So if I want the 4th one, I would do f parentheses 4 of x. That is the 4th derivative, which would mean I would do this 4 times. So let's do some examples of finding higher order derivatives. Example. Let f of x be equal to 2x squared minus 3x plus 1, and we're going to find f2 prime of x, which means I want to do it twice. So, first we would start with finding f prime, because I need that first. So we know that's going to be the limit as h approaches 0. We start with f of x plus h, so that's going to be 2 times x plus h squared minus 3 times x plus h plus 1, and then do minus f of x, so minus 2x squared plus 3x minus 1, all over h. Let's simplify this as best as we can. That's the limit as h goes to 0 of x plus h squared. We already know is x squared plus 2xh plus h squared, but I'm multiplying that by 2. So that becomes 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. And then I still have minus 2x squared plus 3x minus 1 all over h. Let's see what can happen here. 2x squared minus 2x squared, those cancel out. Negative 3x plus 3x, those cancel out as well. Positive 1 minus 1, those cancel out as well. So we're left with just 4xh plus 2h squared minus 3h all over h. All of those terms have h, so cancel it out. Limit as h goes to 0 of, that becomes 4x plus 2h minus 3. Plug 0 in for the h, and you get 4x minus 3. So that's f prime. I need f2 prime, which means now I'm going to do this again using this one. So now f double prime of x would be the limit as h goes to 0. I'm going to use this now. So plug in x plus h into here. You get 4 times x plus h minus 3. And then minus that, so minus 4x plus 3 all over h. That's going to be the limit as h goes to 0. Distribute my 4. 4x plus 4h. 3's are going to cancel out. So we're left with just minus 4x over h. But then notice here we have 4x minus 4x, so those are out of there too. So we have the limit as h goes to 0 of 4h over h. Cancel out the h. Limit as h goes to 0 of 4, which we know is 4. So f2 prime of x is just equal to 4. Alright, so that is how I take the derivative. And so if you have any questions about that, please let me know.